In this video, we'll be talking about average, initial, and instantaneous rates of reaction, specifically how you can use a concentration versus time graph to extract these different pieces of information. In any reaction, you're going to have an initial concentration. The reaction will start with this initial concentration, and over time, the concentration will decrease. And you can use different points in this graph to extract rates, average rates, initial rates, and instantaneous rates. The first thing we'll do is we'll look at an average rate of reaction. And to do this, we can look at more or less any point on the graph. We'll zoom in on this section. So we've zoomed in on a section of the curve. The way to work out an average rate is to pick a time frame over which you're going to take the average rate. So if we pick two different time points, we measure the average rate of change over that time period, we can find an average rate. To use a graph to find the average rate, all you have to do is draw a secant line between the two different time points on the curve. You then have a straight line, and you can find the slope of a straight line by measuring the rise over the run. If we want to determine an instantaneous rate of change, we need to use not a secant line, but a tangent line. And you'll probably remember from pre-calculus or calculus that a tangent line is simply a secant line where the 2 points have effectively been pushed together to become 1 point. If you take the slope of the tangent line, you'll find the rate of change at a single time point, an instantaneous rate of change. Now, when you do this, it's actually really bad to do it from a graph manually due to the difficulty of drawing tangent lines. It's way better to do this using a computer graphing system. And even better than that is if you can use an integrated rate law. For an initial rate of change, what you do is you take an instantaneous rate of change, but you do it where the time point is the initial time point, so t equals 0. So again, drawing the tangent line at t0 is really difficult to do. You're better off using an integrated rate law than doing it manually.